Just the other day, I was exploring in Blender and I was using the Vertex paint methods, which I found to be super helpful. And I figured that they could probably be integrated into Grasshopper. And so what I created was sort of this dynamic link where you can actually paint mesh vertices in Blender, and then you can quickly streamline them into Grasshopper and use them in what this tutorial will show you as a scattering method. I just quickly made this little demo of people being scattered on paths, and then trees being scattered in, or a variety of trees, so a couple different types of trees being scattered in the wild white area. Yeah, this is what this tutorial is going to explore. So let's jump into Blender. Okay, we're in Blender. Blender is a free program, so please go and download it. I highly recommend it. It's a great alternative to Maya in Cinema 4D and 3ds Max. So I really enjoy it for modeling like polygon stuff, and also has a lot of sculpting, texturing, rendering, and it's all free. So what can you not like about it? I'm gonna be spending more time dedicating some videos to Blender because I've been getting into it more so. Anyways, so we're here in Blender, and all we're gonna do here is just quickly paint a mesh face. We're gonna start off by just typing A, then we can just delete just to remove every one of the base elements from the scene, like the camera and whatnot. Then we can do Shift A, and we can just click on a mesh plane. And what this will do is it'll bring us just a simple mesh plane, which we can use. Then we're gonna go over here to the edit mode. And once we're in the edit mode, we can now right click and go to the subdivide. And this will bring up a new menu where we can now specify that number of cuts that's being brought in. And we want to sort of have a high enough resolution to actually see the results of the painting, because there's only one color per vertex. So I'm just going to bring it in as 50. So we're going to get a high density mesh. Okay. Now that we have that, we can go over to Vertex paint mode, which will bring us to this new thing. And now we can see that our mesh is set to this, what is this mode called? Viewport shading mode. And the initial color for me is going to be white. And so I'm going to actually want to dial this all the way back to black. And now, and we can go over here to the object data properties and go down to vertex colors, just so we can be able to see, and I can minimize these. So all these vertexes are going to be painted on this color layer, and that's okay. We can just leave it like that, or you can rename it and do whatever you want. And also, so you can adjust your paintbrush size here, and the hardness and strength to get a variety of results. But let's actually, I'm just going to go back, and just for now, we're just going to keep it really simple. And let's reduce this radius, and let's just go back and paint something similar to those paths that I had prior. So as you can see, this is just assigning a color to each vertex. It's really easy to use. I'm just holding down the mouse and it's basically doing the rest for me. Maybe let's scale this down a little bit more and paint some additional side paths. And another one. Maybe a little island. Why not? Okay. Anyways, that's all we need. It's really quite simple. You can change your colors over here, and then you get this. But what I'm going to show you right now is kind of a critical point. Is when you go over to the shading, the actual rendered scene, you're going to notice that our plane does not have any color actually assigned to it. That those vertex colors are not attributed to the actual like shader texture of it, which is something that we need to save when exporting. What we're going to have to go over to the shading tab. And now if we go just to the object mode, so once again we can see that there's no color. But so what we're going to do is we're going to need to assign a texture to it. And so we can just click this plus and it'll assign a material 001. And what we need to do is we need to input an attribute into this base color. So we can go over to just add input attribute, place it, and assign it to the thing. And right now it's just doing a default because there's no, but if we remember that cull, we can now bring that in. And now you can see, if I just go back to the basic layout, And if I go to the rendered view, you can see now our mesh actually has those colors. And one of the beautiful things is you can also layer this. So you can actually create secondary painting of different colors on top, and you can blend them and create different transparencies of each one. We're not going to do that right now, but you can explore that on your own. Anyways, that's just the base. So now we have a mesh that actually has colors. So let's quickly just export this and just select the mesh in object mode. We can go to export, and we need to bring it out as an FBX because that actually holds the color values within the file. And I'm just going to name this Vertex export colors. I'll just do 3. I had previously done this prior, but as you can see, I tested it out. And one other thing that we're going to want to be able to the only other setting we need to change is that we want to make sure that the Z is up. In some engines, Y is up, and in some engines, Z is up. In Rhino, Z is the vertical because it's not a game-based engine. So yeah, just be sure to change that so it comes in flat the same as in Blender. Anyways, now we can export that. Okay, let's go back to Rhino. Okay, we're in Grasshopper in Rhino. And what I want to do is I want to not just import the file, but I actually want it to be alive so I can continually update that Blender file and see the changes live dynamically happening within Rhino space. So we're going to use an import node, which is called import 3DM. And you can see what this wants to do is a location of the file. And what we can do is just go to our file. Sorry, I have it on my other screen. But I'm just essentially going to take that FBX and copy as path. And then I can just export that. And then if I do double backslash, I get a panel. And now I can just Control V and paste that into the panel. And now what we have is a path that can be dynamically, illegal characters. I already know why. It's because it brought in quotation marks when copying. So if you remove those quotation marks, now we can see we have that path and that file baked into sorry. And now we can see we have that path, and it is brought into the Rhino space solely through this component. So now if we go back to Blender, we can actually just want to show you how dynamic it works. So if I just go and let's just say I want to paint an additional path that happens over here. And that should be good because I'm still painting to that same group. It's already working out. So if I just go to the object mode, or it's already applied to the texture. So if I go to the object mode now, I can go object export FBX, and I can just overwrite that existing file. And now when I go back into Rhino, I may have to recompute. And you can see there's that new path. I had to double check there was actually the new path. I didn't remember exactly where I put it. Okay, so now this has done about half the work for us. We've brought in a mesh. I'm just going to store it in a mesh container and then hide this. So we've brought in a mesh, but now I want to actually be able to select these vertices so I can assign objects to those points. And I want to break it into 2 lists because we only have 2 colors. So I just want to be able to say, so let us see what happens when we can extract those colors from those mesh vertices. So we can do deconstruct mesh. And what this will do is bring out vertices, faces, colors, and normals. And right now, we're only going to be concerned with the vertices and the colors. So right now, you can see that this is outputting a list of colors broken down to RGB. So there's three integers that make up, or I guess floats. They can also have decimals if they want. And and they make up this list of the values for each one of these points. So I'm going to somehow need to be able to compare these and separate it into two lists. One being black, so at the 0, 0, 0, and the other being at the 255, the white. So I'm gonna actually need to break this down into a point. But I'm just gonna quickly show you. Let's just bring in a sphere, and I'll show you how this can be controlled. So here, I'm just gonna bring it down here. Okay, so I have a sphere, and let's just bring a custom preview to show the actual color. And now let's bring in an RGB slider so I can create this, and that's going to be controlling the color. I'm going to hide these guys. So right now we're just going to be looking at this guy. So it's starting off. So let's bring it 255, 255. 255. So if I do if I create a preview, and I can actually see the material color override in Rhino space, I can see that 255, 255, 255 makes a white, and of course all the gradients down will give you all of the other ranges within the RGB color space. So 0, 0, 0 gives an all black. So we need to be able to somehow sort in between these. So what we want to do is we actually want to be able to give, here, I'm just going to create a panel to show you how it's output. So it gives us 3 values, which change based on obviously the color. So what is a good way of extracting 3 different values to compare? And that would be to use a vector, which is made of 3 different values, or a point, which is also made of 3 different values. So let's see if I just plug this color into a point component. What does this give us? This also gives us a -1, -1, -1. But in this we can use because we can actually deconstruct this points now. So now we've taken it one step further, and now we have a single value that represents the color, which we would have to either blast it apart with a concatenation or use something which is called color to point. But this is in the pufferfish library, so I don't really want to use that just because that would require additional plugins, which I'm trying to avoid. So anyways, so right now we can just use this value. And what we're going to need to be doing is, so if -1 is black, then we can go, if we go above 255, of course, it just defaults to 255. So we could, and so what we're going to see is -1 is black and 1 is white. So if we separate the lists by just saying below 0 and above 0, we should be able to discern between the white points and the black points. Okay, anyways, let's hide this guy and just shoot it off into the distance. Okay, so let's use this. Let's just convert this into a point, and we don't want to see those points because it's going to be all between 0 and -1, so it's not very nice. And then let's deconstruct this point, or you can deconstruct the vector, doesn't matter. Now we're going to be getting all these values between 1 and -1, and now we're going to just say greater than. Or actually, let's use a nice little expression just because it's a little bit nicer. So let's say, so the value, let's just separate it and be like greater than or equals to 0. And actually, let's change this as being the cutoff variable. So now let's bring in cutoff, and now we can do -1 less than 1. And now I have a slider that goes in between there, and actually I want to add some decimals into this. You can now see we have a range on the slider, and that will be our cutoff. And then we can just plug this into here. And what this is going to output is a Boolean value. False, true, false, true. And right now we could use just the X, Y, and Z or just the X to be able to discern between the values because they're all the same. It's either, as you can see, it's like 26, 26, 26, 26, 240, 240, 240, 255, 255, 255. So we could use the X just to determine all of them. But when we bring in multiple other colors, we might actually want to use we want to make sure every single one of them is above that cutoff, not just. So I am going to just bring in each one of these and bring each one of these X, Y, and Z through that expression. And of course, these will all be the same because of our condition. But if we were to change this to an RGB or a more varied, here, let's actually preview that again. To bring that to a more, with more variety of colors, you could still use this cutoff now. Because, a red won't, it'll be 255 in the X, but the Y and the Z will not be. It'll be zeros there. So this cutoff thing wouldn't work. So now we're going to use a handy thing called AND, which means that we want, if this is true, I also want this to be true. And I want this to be true. So it can only pass, the only points that are passed through those threshold is if all of these are true. That's what this is saying. So this has to result to a true, this has to result to a true, and this has to result to a true. And then we're getting the same list that has true and false values. Okay, so now the easiest way is to just use a dispatch, because we want to take those vertices and dispatch them into two lists right here with this pattern. And now let's just put some points containers just to show. And you can already see that if these points are above or equal to that threshold, then they're being stored in this container. And you can see as we lower that threshold, more and more points are going to be isolated. How nice is that? And what this is doing is already separating into the other list. So inversely, this is if it's less than the cutoff, which is towards the black values. So there's not that many actual true black values. But if we actually increase the threshold just slightly, we can start bringing in those grays and whatnot. So this is a pretty powerful way of separating these lists. Okay, I'm going to delete this. So now that we have those two containers, which I'll just bring over here, and I can delete this. I'm going to say these are white points. Oh, nice. And these are black points. And I'm also going to turn on a light because it's getting dark. Okay, so we've now separated it into two lists. Now let's go about assigning actual items to these points. So in the demo I showed, it had, there was high resolution meshes, all which I downloaded on Sketchfab, like the polygonal people and the trees, and they're really high resolution. So I'm not going to use them right now because it will just cause an absolute nightmare to try to do this live. But I'm just going to create a really simple tree model and also a person model. And I'm going to use a mesh representation because I know that it renders much faster. So let's go to the mesh. We can just, for a person, let's just bring in a mesh box, and we only need let's just bring in 2. Let's do a really low res so it works in a high rate of speed rendering. So this will be our person representative. How lovely. And then, sorry, put them on the person layer. Let's give it a color. Okay, so now let's make the tree model, which we want to use. Let's just use a mesh cone. And vertical faces, I'm just going to do 2 or something low. Yeah, let's just do that. And how big should our tree be? There we go. Beautiful. And then I'm going to double Control Shift, double click on this, and then I'm going to do Insert Edge. Go down here. Mesh modeling in Rhino is not the best, I must say, but we work with what we can. And then I'm holding Control Shift and clicking on each one of these faces. And then I can simply use the Gumball Extrude tool to go down and bring us to a wonderfully modeled tree. And right now they're not at the same heights. I know might cause some problems later, but I'll show you how to solve that in Grasshopper rather than in Rhino, so you don't have to worry about them aligning all the heights. Okay, so let's go back to Grasshopper. Okay, so quickly, let's just bring in, let's bring in this guy first. Set one mesh. So now we have this in. We're going to be using the orient component to assigning a actual footprint point to these meshes within the space. So what we need to do is we're going to need to grab these white points, and that will provide that final plane. But we need the initial plane, and we also need the geometry. So we have the geometry, and we have some of the final plane. We're not going to want to use all those points though, but I guess maybe for now we can just try it out. So that's that's the initial plane. So let's just bring that to the final plane. And we have the geometry, but let's first get the start point. So what we're going to want to get is a point at the very bottom of it. So I'm going to do BB, which always brings up bounding box, which gives us a beautiful representation of this. And then I like to just deconstruct the rep, which now give me the faces. And then I'm going to use the item tool to find the correct face that I want. So this is giving me that side. No, I think we're going to want to use here. Let's just put in a number slider. I want to get the bottom face. Okay, so the bottom face is 4. And then I can just input an area. And now all of a sudden you can see I have a point that is at the very bottom of this geometry. Sorry, that one's a little bit hard to see, but I promise you it's there. So anyway, so now we have the mesh, and we also have a point that represents that initial plane. So if I go ahead and plug this in, now we just need to plug in the tree mesh, and watch this. Hopefully it won't explode my computer, but because of the low polyness, I think it's going to do fine. Okay, so now we have, it's actually a completely working prototype of our script. I'm going to just move these guys down, clean it up a little bit. Okay, so now we have our tree representation. I think first we're going to want to go ahead and remove a certain amount of points in this. And it would be nice to actually assign how many trees are in here, because right now, let's see how many white points there are. There's 1,729. So thank God I'm not using a high resolution mesh. So let's go ahead and be able to assign a random number of those points to being that, to be where those trees actually are. So if I just bring in a random component, we're going to be able to assign, so the domain we're going to want to do is we're going to want to use the length of the list length. So we're going to want to use that 1079, right? So if I plug that in, then it's going to be between 0 and 1729. And I think actually if we want to be very specific, we're going to want to add 1 to that, which for some reason, why can't I set, or we can just do an expression right here, which is just x plus 1. And then, so now it's going to give us actually 1 point more, because there's always that dilemma, because item number 1 is actually item 0. It gets a little confusing. So you do want to do +1 in that scenario. And we are actually going to only want to output integers, because we're going to be grabbing the indexes of the correct tree. So now if I output this into here, oh, actually, sorry, that's just the index. And then if we, in the list is this, so we're going to bring this in, and we have now an index. This will just give us 1 point, which we can bring into here, and now we get 1 tree. And of course we can change the seed and go to 444. We're going to be getting a random seed, but we want to generate actually a variety. So let's say we're going to want to do 500. because we're ambitious trees on this. So we're going to the number of random values, and we just input 500 now. And we can scatter 500 trees across. I can delete this, bring this up here. And now I can bring in 500 trees across this landscape. And it works remarkably well. Let's quickly bring in the people model, which we can just quickly Control Shift, Control Paste, or Control Copy, Control Paste. Then I can just assign our little block guy, who's looking really, really sad. Wow, this is terrible. Anyways, it doesn't matter. You can actually go and find good models and use those. Please don't use just my little block people. But I just did that so while you're in this zone, you can quickly do this without having to go and find your entourage and whatnot, which is never fun. I really, truly dislike that aspect. So we can just simply copy and paste this down for the black points. So the length, and then the items that will be used. And I think we don't need 191 people in this small chunk of forest. Let's just bring it down to like 30. And this will be our orient for the second one, which I realize we need to bring in the initial plane from now down here, so this is that base point, and the geometry from here. So now we should be able to go around and see our paths. There's some unfortunate accidents in the forest over here, but other than that, it's working pretty well. We now have our two orients, which I'm going to move over and be a little bit nicer over here for our two objects. And the beautiful thing is we can now play around with some of the parameters, right? Like we can go test that cutoff. So it's either all trees, or on this case, I think it'll go, oh, it never goes to no trees because whatnot. But we can play with the softness of it. We can also go and play with the seed, you know? So if I just type in a random number, I can just use the same seed for both of them. But I can go and, of course, just scroll through the seed and get infinite iterations of this. Yeah, I think the one other thing I wanted to show was quickly to bring in a second model of one of them so you can show how to input multiple of the same item on the same patch. So let's actually grab a second tree. Let's just bring this guy over here, copy. I just held Alt while doing that, and let's create a second tree. And I think we could just do that. Let's just make him a little taller, and maybe his base is a little less harsh. And maybe, just maybe, his stem or his trunk is a little bit taller, like that. Wow, that is terrible, but kind of funny at the same time. Okay, so now we have tree number one right here. So let's just duplicate this whole thing, this whole script, and set this as this. So now we have the second tree, and it's the second base point. So I'm going to bring this down here, and I'm actually just going to bring all this down here so there's less crossing of wires. Okay, so we need to now take these white points and actually separate them into two different lists, which we can do in a variety of ways. We could either dispatch the points at the beginning to separate them, or we can dispatch the indices. Let's just, for simplicity's sake, dispatch the indices. This right now, we'll just take it and split it in half because we have a pattern, which is true false. So it'll take one indice and go to the top, to list A, and then one indice and go to list B. So we can just leave it like that. And now we can actually, quite simply, copy this. We're going to, once again, need to replace that center point here. This is called like long range sniping, trying to get wires connected from very high level. So now, unfortunately, we have the same tree on both, which is just an atrocity. But if we take those dispatch points, I could go and put this guy in here and this guy in here. And now you can see we have all sorts of beautiful combinations of trees. And this, of course, still works with our live model from Blender. So let's go ahead and say, you know what? I really liked that island that you did before. So let's absolutely destroy it and make it massive. And just put a massive thing on it. So that island is now huge. Okay. So let's go back to object mode because we need to be able to select it. Select, export FBX, resave over the initial one. Settings should still be the same. And look at that, before we could even get back to Rhino, we already had another beautiful island with one single guy in it all by himself in the forest. Anyways, you can go ahead, try and actually use nice models maybe. This is just for the quickness and lightness that I can actually use on this temporary computer I'm using. Thank you guys for watching. Please subscribe if you like my content. And yeah, have a good one.